Welcome to Cybernetica's Research and Development podcast, tentatively titled Science Will Make You Happy. My name is Bogdanov. I am the head of research at Cybernetica. It is my job to make sure that we do just the right amount of crazy stuff while being helpful to the digital societies at large. Joining me today, I have Liina Kamm, senior researcher at Cybernetica, and we will be talking about artificial intelligence. Could you introduce yourself?
Hi, I am Liina Kamm, and as Dan said, I'm a senior researcher in Cybernetica. I work on the privacy-enhancing technologies, and lately I've been looking into researching the security and privacy of AI systems.
Fair enough. Anything cool happening right now in that regard?
In AI?
No, in your work on AI.
In AI, yes, because it is a field that is very, very quickly developing, as most of you probably know. And I think that is also why we kind of branched into the security and privacy aspects of the topic, because AI uses data, and the issue with using a lot of data is still that we need to be sure that the privacy and the confidentiality of that data is kept, even though we want information out of those data. So we want to have AI use the data, but use it in a way that we can protect people, we can protect their privacy, so that no information that shouldn't be there actually doesn't get there.
I hear there's a deadline approaching, so there's something that you're delivering right this week.
Yes. We're the project that we're currently working on is kind of a risk assessment or risk management methodology for AI systems. So we're trying to get organizations who are working, either who are deploying AI systems internally in their organization, or who are building AI systems as a service for outside use, to have them actually consider different risk management aspects of the AI systems, because the AI systems bring along with them hidden stakeholders that you might not initially think of, and they also have different requirements that must be met for the system to be securely and privacy preservingly adopted to the system.
Mm-hmm. Cybernetica, one always has to ask, which government are we doing it for this time? So.
Oh yes, well the report that we're writing is meant for the Estonian. It's not only for the Estonian government. It is a government procurement for the Information Systems Authority, but it is actually funded in part by the European Cybersecurity Competence Center. Mm-hmm. Through the Estonian National Cybersecurity Competence Center chapter, which is in Riia. And the methodology, we in the report, we do consider Estonian aspects to a great degree. However, I think it is very well generalizable also easily generalizable to Europe, maybe less so to the United States or to other countries, because we focus a lot on GDPR. And I mean, if an organization is trying to deploy systems in Europe, then definitely this is the report for them. But if they're I don't know, if a Singapore company is trying to deploy AI in Singapore, then maybe less so. But again, it is generalizable to exchange GDPR for the regulation that is currently in the place where you're deploying or working.
For the acronym likers, then GDPR is the General Data Protection Regulation. And yes, data protection obviously is a thing. And given that your interest is in privacy, do you have a personal story for why AI matters to you, or why this is why did you pick this? Is there a narrative here
Well, I mean, I come from the privacy technologies and privacy enhancing technologies angle. So I'm very much of the mind that you can. That my research has been on this for a long time already, on this topic, and I think that you can analyze data, you can get the information out of the data without actually breaching anyone's privacy. So that is why I think that it can be also done in AI, because for AI and machine learning, you have different kinds of data in the system. You have people's data. You might have intellectual property, but also not only the training data, but you're also working with the model itself, and the model itself can also contain data that could reveal something about the training set. So it's not, you might think that, okay, I took all of these data and I made a model from them, but it doesn't it doesn't always aggregate out the actual information in the data set. So you could infer based on the model information about the people who are included in the data set that the model was trained on. So I still want to kind of somehow protect the privacy of those people as well. So that's my angle for the research and why I came to AI, because I think AI is a very useful tool, but it is like a hammer. Not every task is suited for AI to solve. You always have to be careful how you use it, and you have to be you have to know how to use the tool. And the learning curve is not well, for some tasks it is high, but for some it isn't really very steep. You just kind of you can start small. But the point is that like with a hammer, you might still hit your finger, or I guess not like shoot yourself in the foot, but like hit yourself on the foot. So it's you have to know how to use it and to be careful on how to use it. And I think the work that we've been doing with privacy enhancing technologies, it also kind of builds into the same kind of thing that we're doing with AI now, and it's the risk-based risk assessment, the risk management-based approach. So we are applying the same methodology of first you map your organization, you map the task, you map the data flow, you see who has access to what, who needs to have access to what, and then based on that, you can actually see whether you need all of those people to have access to all of those data, or whether you can minimize somehow, or so have it be kind of privacy by design and by default. Also in the AI systems.
That's a very big dream. I already had many questions here. So, as much as I understand artificial intelligence these days, it's heavily based on machine learning, and there the model is. We talk a lot about models. OpenAI has models. Meta has models. Estonia has models. But these models are like a lot smaller than the data. So, but still, you say that there's a possibility that they contain something that can leak.
Well, yes, the models are smaller than the training sets, but they are still very large. They still contain a lot of attributes. They still contain a lot of data. So it is not like you take a data set with millions of, or let's say billions of rows, or what you take a lot of free text, for instance, and train based on that. And then you get this kind of like small, compact model out of it. It's not like that. The models are actually fairly large. So that also, they contain a lot of information. But it is possible, yes, to based on a model to infer whether a person was used in the training set, or whether a person's data was used in the training set or not.
And that could constitute a leak of privacy,
yes, of course, yeah. Yes, because again, it depends. Because when you're training the data set, we are assuming that whoever is training based on the data, training the machine learning model, we assume that they have the right to process the data set that they're training the model on. But then when we so the researchers have this or the developers have the right to use this, but the question is whether the people who the model is given to use in inference, whether then the model is actually legal to use for them. So whether they are allowed by regulation to kind of process the data forward. So that is the aspect. So what we want to kind of do is to have the models be usable later as well, but be sure that they don't actually output anyone's specific values.
Okay.
So you have to hide the model, because the more access you have to the model, the easier it is for you to or for an adversary to attack the model. So if the model is hidden, then it's more difficult, but again, it's not impossible.
Okay. We could likely just dig on AI security for a while, but we might get back to that a bit later. Coming back to that report, to the Information System Agency in Estonia. So once it gets published, who should be looking at it? So who is it for?
So for the report, I think the target audience for the report is are organizations who are deploying or using AI systems in their workflow. So it is both for just the organizations who just like buy a tool that has AI and then use it within the organization, but also for those who are developing AI themselves and are selling it as a service or as a product to other customers.
So if I think that it's a great idea to put a chatbot based on ChatGPT on my website, then I should read it.
Yes, you should. But again, if we're looking from an individual point of view, then you're not probably going to do a risk assessment and total catalogization of all of your data if you're like a separate person, like an individual person. So if you are using ChatGPT, then there are things that you might consider also, but I think the report might not be for the individual that way. But the actual procurement also includes educational videos. So there are going to be, in addition to the report, which is, I think, going to be out, I think this week, at least, then there are going to be additional videos, which are, I think, coming soon in June of this year, which might actually be for you, even if you are an individual user of an AI system. Because the videos, there are 5 videos. One of those is going to be a general purpose AI introduction and considerations video. So that one is the one I think you should watch. It's going to be approximately 15 minutes. So it's not a long video. It's easy to, it's approachable. It's an approachable timeline, I would say. And that one I think is going to be helpful for the individual as well. Because there are, as I said, there are kind of hidden stakeholders and hidden issues with the with different AI systems, which you might not consider. I mean, there are hidden stakeholders in different, like in social media as well. But I think for AI, you don't even consider that when you're asking a machine translator, like you're using Google Translate to translate your text, then you're not thinking about when you're like, okay, I put my text into it and then I get a translated text out. Great, right? But you have to think about what you're actually pasting there, whether the information that you're pasting into that translator box is okay for Google to see. And that is a thing that not a lot of people consider, that it's also like you're basically putting it up on Google. Google is going to store it. It's not going to like delete it. It is improving its improving its service. So it is legitimate interest. They have, because you put it up there, they have a kind of right to store that information and then later use it for making their service better. But that is why I think also the individual could watch the videos. So of the 5 videos, the first one is going to be general purpose, and I think that the target audience for that is actually like anyone who is interested in the technology. So I think we're trying to make it so that even high school students who are interested might be able to kind of look at that and get maybe an idea of what they're dealing with.
High school kids are likely advanced users of ChatGPT already anyway.
Well, yes, but then kind of think about what you're actually inserting into ChatGPT.
So what you're saying is that if I put something in the ChatGPT box or in a Google Translate box, then that is content that might end up in their training data later on, and somebody else might see it somewhere in some inference. Or did I get that right?
Well, I think ChatGPT has options where you can basically say that do not store my queries.
Okay.
But like if you want to have a query history, then you need to store the queries.
Yes.
So, and that is like it is a very user-friendly thing, but then you're storing the queries, so they're storing the information. With that Google Translate, I don't like that is freely available. It has been available for a long time, and I'm pretty sure they do store it. And I mean, again, they are using it to make their models better. But and sometimes it's okay as well, because sometimes you're fine with your data, like your text is not that let's say secret, or maybe you get some something that you want to quickly translate into another language to be clear that you understood correctly, and it's publicly available information, then it's totally okay. But sometimes you get an email and you want to be sure that you've translated it correctly, and it might come from, I don't know, some government or somewhere, and then you paste it there, and it could be sensitive information.
Got it. So these kinds of sensitivities that report is telling us about. So what should we think about when we put something somewhere?
Yes. So it is based on the same kind of asset management that we try to propagate everywhere. So to have you, like if you're either creating a service or taking a service into use, to see what kind of data sets you have and how the data flows between them, and when the data flows from one stakeholder to another stakeholder, who actually gets access to your data.
Okay. Just last year and right now in Estonia, the discussion it's being had is how will our industry be more competitive? So our companies, how they become more efficient, how they do more with less people and for less cost. So companies are looking at AI options to optimize their work. So if I'm an Estonian lumber mill or someone, then if I start using if I read this report, will there be something in it for me if I don't have security experts or AI experts at work? Is there something in me that's like easily digestible?
I think yes. So we do kind of say that it is the methodology that we describe is very compatible with different risk management methodologies. So the ISO 31000 and ISO IEC 27000, which is information security specific, and the NIST frameworks, and the Estonian information security standard as well. But if you don't have any of those standards implemented, then it is still kind of the methodology is talking about how how to include AI systems in your existing risk assessment or risk management methodology. However, you can actually just read it and see what the threats and threats are to the system, and what are the controls that you can use to kind of circumvent these. Mm-hmm. So you don't have to officially implement the risk assessment or risk management methodology. Mm-hmm. However, you can still do the mapping, still look at what the who the hidden stakeholders are. Yeah. That is an easy thing to do, I think, even for a person who is not information security, not an information security expert, because then you're still kind of your own processes, right? And then if you're talking about an AI system, the rule of thumb is if it is on the cloud, the data is going out of your organization. So if you're kind of taking a model and deploying it inside of your organization, then the data is not going out of the organization. So, I mean, that is kind of, you don't have to do it at a level of a level of assurance where you can get a certificate afterwards. Mm-hmm. But even the basic level of thinking about where your data is moving, whether it is within your organization or outside of your organization, even that is already better than not like thinking about it at all. So I would say yes.
So
useful for everyone.
If for many organizations, standards and processes, there's another word for them, and it's called bureaucracy. So are there checklists that I can quickly tick off on?
Yes. We do have a kind of the report includes a kind of checklist based a sheet where you can basically fill in based on your own data. So it is made fairly simple for any kind of user. So we try to kind of give different layers so that it's compatible with risk management methodologies, but also very easily implementable for someone who doesn't have all of that kind of framework in place, but they still want to be careful with what they're doing with AI.
That's a total relief. So, so it works like this. So if somebody comes to you with an idea of an AI application, and then using this methodology, you can analyze it and tell them how to do it better. So I wonder if we try to, can we go through some of it here? Can we take some example application and then open up some of the aspects? That would
sure.
Right. So now we just need to figure out an application. So imagine I have a distant relative called Rita, who is very worried about the safety of traffic and cyclists. So people riding bikes. Yeah. There's a lot of bikes. There's bike sharing. There's people who haven't seen a bike before and they're driving one. So the question of do they have a helmet? Do they have all the lights? Is everything in order with the bike? So Rita has this idea that there are public cameras outside for safety, public safety. So could we use the video feeds of those cameras to, first of all, detect how many cyclists are not using their safety equipment? So can this be done first?
Do you mean technologically or?
Technologically, let's talk. So is this an AI? Is this an AI problem?
Well, yes, it technologically it can be done with AI. So AI is fairly advanced by now, so we can detect different details from images and from video. So this is not a very difficult task. So you don't have to create a whole new machine learning system for this or a new machine learning algorithm for this to work. You might want to create a new system, but you don't need to do the algorithm because you can use existing algorithms for that.
Mm-hmm. Okay. But
regulatorily,
okay, I sense the but coming.
Yes, yes. There like regulatorily, and whether you actually and like from a social aspect, it is you have to again consider what is the advantage of the system and what are the disadvantages of the system, and whether one outweighs the other. Because there has to be a balance there. So, like you want to. So many issues. Sorry. Like first of all, and again, why is she doing this? Is she doing this for assigning fines to people who don't have helmets, or is she doing this for I don't know, some kind of statistical research?
That's a good one. I actually didn't think of that. Yes, you could immediately do facial matching and assign fines if they don't have a helmet. That's a bad idea,
yes.
Right? Okay. Thought so. Right. So, but for this discussion right now, let's consider that it's a statistical thing. We just want to know what's the percentage of people riding bikes in city center who don't have any safety equipment and who are potentially endangering themselves or somebody else in the process. And then we'll have educational campaigns if we know that there is too many of them. Okay,
but then she's doing a research project, basically, a statistical research project.
Yes, now that you say yes, and if you put it that way, it looks like a research project. It could totally be a research project.
So because there is a difference again, and this is already goes into data protection regulation territory. But the issue is that why these cameras were put up. So the data collection for those cameras has a specific purpose. And it's probably not this. It's probably not the looking whether people have helmets during bike riding. So this would be secondary use. You're collecting data for one purpose, and you're using them for another purpose entirely. And this is not okay in the general sense. Because then you would have to say that, okay, this is why we're collecting the data. We're also looking at this. If you're doing it for research purposes, then that is allowed. You're kind of allowed to then, if you find this out, then you can do the campaigns. So it is a bit easier there. But I think if you're dealing with biometrics, and because you're dealing with biometrics, you're looking at people's...
What are biometrics?
Biometrics are people's physical and behavioral traits that identify a person.
Okay.
Some of them uniquely, some of them in combination. Yes, your face, your iris, your voice, your gait, your fingerprints. Those are all biometrics.
Okay, and they're special because?
They are personally identifiable information. So they are very much, these are very protected information. So because these are things that you cannot change. You cannot change your fingerprint. It's very difficult to change your gait truly so that the machine learning algorithm doesn't find you. And these are things that you can basically identify a person from. And if you want to analyze these data, then you're analyzing personally identifiable information. And we don't actually want to analyze these data unless there is a specific need to do that. So in those cases, and now I'm going into the privacy enhancing, I'm putting on my privacy enhancing technology hat,
right.
Because you always want to minimize the amount of data that you're using, and you don't really need to know a person's identity to do statistics on how many people are riding a bike without a helmet.
True.
And for you have to use at least pseudonymization, which takes away the personally identifiable information. So all of the biometrics go out the door. So or better yet, you want to use some form of stronger privacy enhancing technique so that you don't actually get any, let's say, secondarily identifiable information either. Because there are a lot of attributes that define us uniquely, which in combination define us uniquely, but on their own do not define us. So, for instance, your let's say your year of birth doesn't really define you uniquely, but if you stack on, like, I don't know, hospital visit dates and the year you got married and some other, like when your children were born or something like that. So you stack on a lot of those, and then a person becomes identifiable because they are at least, well, even in the United States, but especially in a country the size of Estonia, which is 1.3 million people, and that's million. So it's not a lot of people at all. So you probably already know a person. Like if you know a person's when their children were born, which you, like for your friends you usually do, then it kind of you can find them in a data set fairly easily.
Okay.
So
hard to hide.
Yeah. So yeah, but that's a tangent on on privacy enhancing technologies. So yes, but coming back, the biometric information is very sensitive. So we want to avoid analyzing those data if we can. Yes.
Well, here technically the people walking are not the interesting ones. We need to identify the bike ones riding a bike. And
so we don't actually need the biometrics information to be in the data set. So we can.
They're there in the video anyway, right?
Yeah. But the point is that when you're training a model, you can say what you're looking for, or you can like tell the model that you're looking for someone on a bike, and you don't really need their facial traits to be in the model. But to actually train the model, you have to give as input this video, which has the information. You can't really. You can probably do some video manipulating, and like again, it is a very difficult task, I would say, that you've chosen for your relative to do, because she chose it. Great. So I would say, and because you're working with biometrics data, which is personally identifiable, then you would probably also have to get an ethics committee approval.
Right. But okay, let's go for a moment. We might have to come back to that. But if anyone wants to think of something like this or simpler, then how do you... do I need to have a degree in computer science to do it these days? Do I need to train my own model to do it? Or what's the way? If I wanted to, based on today's technology, build something like that, then how would I go about doing it?
Well, I mean, it depends. It highly depends on if you have a degree in computer science or let's say data science. It is easier for you to deploy models as well. I'm pretty sure that you can get this as a service. But then if you're buying this as a service, then you get the additional use case that we talked about a bit earlier, when you're actually taking the data that has biometrics data in it, and you're uploading it to the service provider. So at least the service provider can see those data as well. If it's like for video editing and video training based on videos, it takes again a lot of computing power. So those kinds of trainings are usually done on the cloud. And when you're doing this on the cloud, then the cloud is always someone else's computer, so you are uploading it somewhere else. And even if the cloud provider is a trusted cloud provider, they still have access to the data. And And the issue is also that, in Europe, GDPR doesn't actually allow you to transfer data, personal identifiable information outside of Europe without different kinds of. You would have to either have consent from the people, or you would have to have a very the ethics committee has to approve this. Mm-hmm. With US right now, there is an agreement, but the agreement, there have been previous agreements which have been revoked, so we're not sure how long this also works.
Right, and most of the big AI service providers, I'm assuming, are from the United States.
Well, yes, most of the, if you think about a cloud, the cloud is usually somewhere else. They do have subsidiaries in Europe as well, so they have their they're registered in Europe as well, but most of the data still kind of goes to the States. I think you can pay more to have the data be in Europe, but the mother companies are still going to be somewhere else. So there is an issue of what they as the mother company can do to get the data.
Right. So if I'm processing something that's high risk, that's very confidential, very sensitive, then this is something I should take in mind when I plan my system.
Yes, because it is. I mean, if you made your risk assessments and you have accepted this risk, then it's fine. And it is as with any kind of risk assessment. It is that is why it is done, because we can always it is a very good example that for instance, houses in Estonia, they're not built with earthquakes in mind because we don't have a lot of earthquakes. So what we're doing is we're accepting the low risk of earthquakes and building houses that won't resist earthquakes, because they would be much more expensive to build if there were earthquakes. Mm-hmm. But on the other hand, if we're talking about a lot of snow and making roofs of houses be resistant to piles of snow, then for us to actually, that makes sense for us to pay that money to have them be resistant because it happens all the time. Whereas if we're talking about LA, then it doesn't make sense for LA or someone in, I don't know, Portugal or Spain. It doesn't make sense to have all of the houses be resistant to piles of snow, because that rarely happens. So with risk assessment, it is the same way with the risk assessment for when you're doing a risk assessment for this kind of AI service that is somewhere outside of your company or outside of Europe, for instance, or wherever.
To drive the same analogy further, then it is currently, I think, the case that the houses have to be built, meaning that the AI systems are going to be built. Yes. So some will do more risk assessment, some will plan for earthquakes, some will have a tent and hope that this is the case. But so technically, the idea, I understand it, I could, sorry, not me, of course, it was Rita, yes. So if she wants to do it, then she has to take the video. One option is to give it to an AI system provider, someone has an API or something, upload there and then get it back and saying that there's a cyclist in this frame or in that frame or like that, and it'll obviously detect helmets. Computer vision can detect helmets and stuff these days, right? That's what we have been doing all the CAPTCHAs for, I guess. Yes, all those CAPTCHAs.
You have been training
I have been training the AI all the time.
Are you better, though, than the AI with the CAPTCHAs, though?
In some cases, then I think I can identify bicycles on pictures on a CAPTCHA very well.
Okay, but
now.
Are you sure? Because I'm never sure with the CAPTCHAs, though. I'm never sure whether I'm supposed to identify this traffic light. Am I supposed to just take the ones that the lights are in, or am I supposed to take the whole structure into account? So if we're talking about bicycles, are you also taking the bicycle rider into account, or just the bicycle, or if there's like a tiny piece in another frame, are you taking that one in as well, or how does that work?
That's a good one. I mostly well, sometimes again, who doesn't know what a CAPTCHA is? When sometimes a computer asks you to look at a picture and then click some squares which contain traffic lights or bicycles or
buses.
Some buses, yes, or
Tractors.
stairs, tractors, and well, this is all used to later train computers to identify these things themselves. But here we are actually. I think how they solve this. I usually don't have the bicycle rider. I only pick the bike.
Well, yes, I do too, but I'm not entirely sure what the rules are there.
Well, if you ask 1 million people and 900,000 of them pick just the bike, then I think statistically they just throw all the outliers away and think that this is good enough. So, okay, fair enough. We have successfully, me and you and maybe many of our listeners have successfully trained AI to detect bikes. Hopefully also somehow it can detect helmets and the bike riders, even though we never click those boxes. Right, so I get the video goes there. I get back some sort of a list of bikes, and I guess understanding whether a helmet is connected to the bike via a rider is a harder problem, but I guess this can be done these days. So it should be doable, right?
Yes. It's, I mean, at some point it is, it depends on how the model is trained as well. So if you, what kind of algorithms you use to train the model, and whether they're supervised or unsupervised, meaning that whether a person is actually helping, like you said, like training that, okay, this is a bike, or whether the computer is trying to figure out by itself whether this is a bike or what is it.
It probably thinks that this is object number 7, and then a human comes along and says, yeah, okay, you found the bikes. Job well done. Okay, but assume that it wasn't something like this, and I would need a special model. In that case, I would need to have infrastructure to run them. I would need to get the model from somewhere. Assume there's a company who sells me a model for detecting bikes and riders.
So what you're asking is whether you can do it in-house on premises in your own organization.
If I'm one of those people who is afraid of snow or earthquakes, then can I build things without sending stuff out?
Yes. So what you can do is, the easiest way is, of course, to just buy the service, to have someone else do it for you, and well, hopefully they are good at this already. Another option is, yes, to actually buy the model from someone who has done it and who is willing to sell it to you. Because again, as I said before, if you give access to a model without it being a service, because in a service, the organization who trains the model, or the party who trains the model, they still have control over the model.
Yes.
If you're selling it as a product to someone else, then they kind of get a bit of that control away from you, because now the model is in-house in their organization, and they have more access to it. So probably if they're using the model for deployment, they can do as many queries as they want. They can do different queries to it. But we're talking about Rita. We're talking about your relative, who is not going to be an adversary, not going to attack the model. So now Rita has more control again over the data. So the data doesn't leave Rita's organization or Rita's research whatever area, sandbox. So now Rita gets a bit more control. However, Rita still has to trust the model provider. So, but she also did have to trust the model provider when she was using the service, because someone else has trained the model. You don't know what kind of data the model has been trained on, whether the model has been diverse enough to kind of detect all of the bike riders, different bike riders. So now it's the same kind of thing. You get more control over the data. The data doesn't need to leave the organization, but you still trust that you have to trust that the model was trained properly. But you can do more tests on that. So
infrastructure is going to be an aspect.
Yes.
Yes.
I wanted to get
yeah.
Because you are going to need all of the computing power to actually use the I guess if the model is already pre-trained, then you don't have to retrain it. You might have to fine-tune it a bit. That's not as computation heavy as the actual training process, but it's still computation heavy. And then inferring from the model and video is quite big, so it's going to take. It's not probably going to be a task for your laptop or for Rita's laptop.
Right. There are some. Well, if she's a researcher, then I hear that the universities have high-performance computing centers, and this is now actually a point where these could be in use.
Yes, and I think a lot of this kind of research is already being done on the university cluster as well, and the university cluster has quite a high security level of assurance as well. So it's
good to know.
Yeah. It has a high security level, I think, is the...
Fair enough.
It used to be based on ISKE, which was the previous Estonian information security standard. Now the Estonian information security standard doesn't have the same levels, but I think they will probably also move to that categorization.
That's good to know. There's infrastructure available in Estonia as well. And well, given that Rita is trying to do research in Estonia, then she might actually be able to find some sort of a deal that works out. Yeah. Fair enough. Very interesting. So, but what is it we should talk about more? We talked about technology. There was the whole idea of how we do it. We can use somebody's AI APIs. We can run our own models. But and then we talked about legislation. There is no regulation on artificial intelligence yet.
Yes, it is. So it was agreed at the end of 2023. They came to an agreement, and in
Europe.
In Europe, yes, the AI Act in Europe, and that is going to be published any day now. But the any day now could be a couple of months or even more, because they need to have it translated to all of the languages, and it's a process. So like, there is an agreement, there is a kind of draft version available, but there's nothing really. We won't know what the actual final version is until the actual final version comes out. So there are different aspects there which govern AI use, but as the problem with these kinds of legislations, same with GDPR, is that the technology kind of develops so fast that from the point of when the legislation was started, or where the development of legislation was started, to the point where it actually comes out, then often the technology has developed past that point. Mm-hmm. So there might be clauses that are a bit outdated already when the legislation comes into effect. And that is, I mean, it's totally understandable. And it might not include all of the technologies, but I think it is a good start, I guess.
Well, we'll see. Europe has had certain success with GDPR, and yes, for others, it's again another form of bureaucracy. But
but with GDPR as well, it's it very strictly kind of regulates pseudonymization, and it says that anonymization is out of the scope. Mm-hmm. However, there are other privacy-enhancing technologies that cannot be considered pseudonymization as such, which are like stronger than pseudonymization, stronger than anonymization even. Or okay, it's another tangent, but the point is that it is it could be a problem that not all of the technologies are considered when in the legislation. So those technologies have to kind of find a way to fit themselves into the kind of hole that is there, or not a hole, but let's say that the kind of mold that is there to kind of fit themselves into there, because it's not that straightforward.
Right. We'll leave that part to the legal experts for the future. But what else should Rita be worried about? There is what will happen when she's actually successful? She actually runs that study, gets all of the things done, everything is legal, gets a report saying that 60% of riders are not wearing helmets or are riding on a bike, 2 or 3 people on the same bike or whatever it is that people do. So,
you do that only on the rental bikes, right? You don't do that on your own bike.
Well, likely the citation needed. So, but the society. So what happens then?
Okay, so I think what you're aiming at is the actual ethical and societal issues. Well, I think that when Rita is doing this as a research project and not on streamed data, so it's not like a live, like everything that comes from the camera goes through a streaming and then goes immediately and gets analyzed and like a person, like information comes out of it. Then if it is done on already saved data, then there is just the information that like 60% use helmets, which is already wonderful, but then
don't use helmets. I think.
Oh, 60
okay.
don't use okay.
helmets. Let's assume 60%
they don't. Okay, so that is not that wonderful, but I think that it is that you can do a social campaign based on it, and that is going to be okay, I think. However, like if you want to, the issues with different aspects like this are that, like if you if you did this as a kind of surveillance, or you wanted to analyze this continuously, then you would get people who actually are going to then you're going to have to let people, well, I mean, you have to let people know that there are cameras anyway, but you have to let people know that you are doing this kind of surveillance. And then in those cases, I'm assuming that a lot of people are just going to ignore those streets where there are cameras, and they might go instead of like, so instead of what you're trying to do to make it safer, you get people to go to smaller side streets, which might not be as, let's say, bike rider friendly, and you could have more accidents there. So the point with, but this is the point with any kind of analysis that you do. So if you get results, you have to be mindful of what you do with these results. Mm-hmm. The point is that now we have the opportunity with AI, we have the opportunity to go through so much data at such a short time and analyze it to such a great extent, and we might find patterns that like give us a lot of insight into people. But some of those insights might not be causality, they might be just correlation. And in those cases, when you've told someone, like for instance, that, sorry, you're going to lose your job in 3 months, then the question is, if they lose their job, whether they lost the job because they would have actually lost it anyway, or whether it's a self-fulfilling prophecy because you kind of get worried that you're going to lose your job and you're not going to perform as well, and then you're going to lose your job because you're worried.
Okay.
So you always have to be mindful of what you do with the results, and especially if you're using so much data and so many kind of categories. One issue with
is the problem using so much data or so little data? Both are bad, I would argue.
Well, yes. When you're using too little data, then the issue becomes that. Are you actually basing, like, and this is with any kind of statistics. I mean, if you're making, if you're trying to find the average height of Estonians and you're looking at 10 people, then really, like, it's not going to be an average of any kind. So that depends on your sample size. And again, if you're training your model based on Estonians, and then you want to and genetics, then the issue also becomes whether you're. I mean, if you're doing this, I don't know, for treating Estonians or finding patterns about Estonians, then fine. But if you're trying to use this later in a larger research, then Estonia is not very diverse. So you're going to miss a lot of information that might be crucial for people elsewhere.
Fair.
Yeah. But I wanted to also talk about explainability.
Yes.
Because you get these kinds of results, and the well, I mean, if you're just looking at like observational things that there were like I don't know 15 people who had helmets, then that's one thing. But if the model gives you a kind of result, then you have to kind of think about this result. Any kind of like you ask a question and you get a result, then you first of all have to consider it with a grain of salt, because a lot of the models are like, for instance, the GPT, which is a kind of generative pre-trained transformer, which basically is just thinking about what the next, what is the most likely word that's coming up next. So in some cases, the most likely word that's coming up next is the word for you, but in some cases it really is not. So anything the model says, you have to first yourself think about whether this is makes sense or not. So, and this is because why we're asking things from the models, we're trying to get new knowledge. So we might not be an expert in the things that we're asking them for, but we still have to kind of think about whether the answers make sense. And this is where explainability comes in. So with explainability, the model is supposed to be able to explain why it got to this result. So for instance, if we're talking about searching through a lot of documents and asking for specific kinds of documents for a specific task, then or like a result for a specific task, then the model can say that, okay, I came up with this result, and the explainability part of that would be that it's going to give you the source documents that it used to get to this.
Okay.
So now you can go into those, instead of looking through 1,000 documents, you will look through those 3 that the information was based on, and you can verify for yourself that the reasoning that the model came up with makes sense.
Okay, that seems helpful. Time is crucial. So when is the report coming out? When can we read this, and where can we read this?
When's the podcast coming out?
Good.
So, well, the report is due tomorrow. From the day, like next day, from the day we're recording this. So basically, it should be available when this podcast is available.
Right.
I'm hoping that the podcast will also feature a link.
Fair enough.
But it depends on how fast the
Okay, very good.
can be uploaded.
It'll be public. Everybody can read this, and it will be in
Estonian, yes.
Right. So everybody else has to read. Everybody
you have to use Google Translate to translate it.
Okay.
Because it's a public, and because it's a public report, then it's okay to paste it into Google Translate.
But there is also, I know, good Estonian machine translation.
Oh, yes. Well, better yet, rather than use Google Translate, there is the TartuNLP translator, which is basically the definitive translator or definitive kind of Estonian language corpus.
Okay.
Yeah. So they have the best Estonian language set that everything has been trained on. So I would say that translator is actually fairly good with translating Estonian.
We'll have to put that link in there as well.
To and from Estonian, yes.
And there is a big piece of news on AI in Estonia.
Yes.
Yes.
Yes, we University of Tartu, TalTech, and Cybernetica are involved in the new program for excellence centers, and this excellence center that we have is the Estonian Center of Excellence for AI, so XI. This Center of Excellence is a collaboration between then the two universities and Cybernetica to develop different foundation models and different applications for AI. And also a lot of the work will be done with the Estonian language and fine-tuning it for the Estonian tasks, fine-tuning different models for the Estonian tasks.
Good, and that'll likely have a lot of work ahead of it. How long is it going to be?
The project itself is 7 years, but we do have a kind of research breakthrough objective based timeline. So, because it is very difficult to propose a plan for developing AI for 7 years, for obvious reasons. Because AI is developing so fast, we didn't know what was happening. Like 2 years ago, we didn't know where we would be this year. So I'm not sure that we will know what will happen in 7 years. So our Center of Excellence is built up in a way where each year we propose research breakthrough objectives, which are meant to be worked on for 1 year or 2 years. And then new objectives come up, and then you could do a continuation to the things that you were working on. But it is basically based on these kind of like shorter term projects.
So, and these are based on what the world has developed and what Estonia needs. So there's going to be practical stuff in there.
Yes. So as I said, we have the foundations part, and then we have the applications part. The applications part is very practical. So there are applications for e-government, for medicine, cybersecurity. So there are a lot of and education, and so a lot of different tasks that we're working on. And then you can, like, every principal investigator in the project can propose their own ideas to these, and then other groups will then join, either as kind of like different stakeholders. So some of them might be like the client side, or asking, like, having a problem and asking the other team to fix that problem for them, or in a sense that, for instance, our work is mostly on security and privacy. However, we would like the actual foundation model groups to help us with the model work, because we do have people where we don't have enough people to actually like start from scratch somewhere there. So because we are hoping to use their knowledge to make the algorithms and applications like faster and more efficient and explainable.
Good. Collaboration, it helps. So that's all we had time for today. Thank you so much.
Thank you. And thank you for listening.
Yes, and remember, science will make you happy.